Hello, everybody. We're having a small technical glitch right now. Nothing that we're not going to be able to overcome here very quickly. Here we go. We've got our third person back, our second panelist. So like I said, I knew that was going to get taken care of very quickly. So welcome, everybody. Just a few housekeeping points. It's the standard discussion points that we talk about at each and every one of these episodes. You've got your control panel and two great important features of your control panel. One is the handout section. The slides from today's presentation can be found in the handout section. I need to go ahead and make somebody a panelist, excuse me, a presenter again. Okay, so that's done. And also, any questions that you have, there is a question section. Please put any and all questions that you have pertaining to the webinar in the questions. We will try and get to those as they come up. I will be monitoring those during the webinar, and as I see something that looks like we could address it straight away, we'll do that as opposed to waiting until the very end for all the questions. And so, okay, with that, again, welcome to episode 11 of ML4Patents.com webinar series, this time featuring PQAI. PQAI is unique to the systems that we've talked about thus far because this is a freely available open source tool. And so I think this generated a fair amount of excitement. We didn't get an opportunity to start advertising for this webinar until a little later than normal, but we still had 82 registrants. So that's a very good showing, generally speaking. And with me today to talk about this system are Sam Zellner and Mahesh Mann. And apologies if I mispronounced your last name. that should have been one of the easier Indian names for me to, or I don't know, Pakistani or Indian. Again, I'm just going to continue to make these cultural faux pas. Apparently, please correct me. Again, I'm Tony Trippi, and I'm the founder of ML4Patents.com. And with that, I'm going to hand it over to Sam and Mahesh for them to tell us all about PQAI.
Thank you, Tony. I appreciate the opportunity. It's a great series you have and what you're doing, and we're just honored to be a part of it. So the background, I was part of AT&T for many years and worked within their patent portfolio group, intellectual property group, and managing the patent portfolio. And had learned a lot from that, and then this new career that I've started here, I'm excited to share with everyone. Also, my partner in crime here, Mahesh, his background is with one of the leading IP analytics companies, Gray B Services, and Mahesh is leading up the development effort under PQAI. So let me just prepare everybody here a little bit, is that this is a little different from a lot of the other Tony's participants in this program, because a lot of the other program participants were companies, and we're really more of an initiative, as you'll see. So I'm excited to share with you about the initiative, and of course, we'll get into the technical details, but I wanted to provide some background. Mahesh, you want to start the slides? Okay, let's give us 1 second here. There we go. Okay. So let me just first start off with giving you a little background on PQAI. And I should apologize. I mean, this is this typical sort of techie approach. PQAI, my wife always says, what a terrible name. Patent quality through AI. As background, I was involved with the first browsers for cell phones, and that initiative was called WAP, and everybody thought that was a bad name. So I guess we're just going to keep on with the tradition here. But in any case, like I said, I was with the intellectual property group at AT&T. Like many of the corporations, we were dealing with a large patent portfolio, a lot of the data and everything, and in 2018, we saw the onset of AI coming in. We were obviously working closely with the labs, and they were talking about what they're doing with AI. And so we got really excited because we really do see AI as an inflection point for intellectual property. And so that's when we started saying, hey, what can we do with AI in the IP space? At the same time, we also had our wireless group had transitioned from basically a proprietary 4G system to saying, hey, why don't we make 5G an open source approach? And so they were engaging the open source community on the wireless standards and wireless technology. And we saw the success there, and we said, wow, that's incredible. They're really doing something that most people thought just wasn't possible. Quite honestly, wireless was all about proprietary things. And so we said, why don't we follow that same route with IP and IP tools? So that's what got us started and got us excited about the whole idea of open source IP tools. So we started it there. Like I said, I retired from AT&T. They allowed me to keep on going with it. And we're getting contributors from companies, law firms, universities, and industry organizations. So getting a lot of excitement here. And I'm pleased to tell you where we are today. We have a prior art search engine that we're very proud of. Again, it's open source. You can go to the GitHub site and download it and try it out for yourself. We also have a server running it, so you can go and try it that way too. So, we're really at the cusp. This is a great time. And again, thank you, Tony, for this opportunity to share what we've done. So let's talk about the vision here. So we're about really driving things and are making major change here. Again, we're a catalyst for creation of new IP, next generation IP tools, AI tools. And one of the things here is that we really want to be inclusive and include everybody in this whole, new sort of generation. Because as a lot of people have seen, and there's been a lot of studies out there, the number of women inventors is not represented in the patent system, or minorities. And the part of that is we believe is that, while anybody can come up with an idea, you really do need tools now. It's no longer a passive exercise of just, hey, I got an idea and just I'm going to go and file for it. I mean, there's a lot of work and analysis. Obviously, you're now competing with the world in terms of ideas. And so you need tools to be an effective inventor in this day and age. And so that's why we feel like by creating these tools, make them accessible, we're going to increase the number of people who are going to be successful inventors. And obviously that flows through driving the pace of innovation. So we're really excited about that. And you're going to see we're really trying to push the envelope. Okay. So why open source, you might ask? Well, like I said, we're thinking about it in terms of really making a difference. And if you look at something like WordPress, great example of an open source effort that really all of a sudden empowered people, anyone, to make a website. And then everybody jumped in on WordPress, starting making plugins and capabilities, connecting it with different things. And that's what's really exciting. And that's what we're hoping to happen here. We're creating sort of a baseline of implementations that people can look at, or sort of a model that people can look at for different implementations of AI tools. And we're hoping that people can build on them, people can contribute to them, and just build it out. And one of the things you're going to see is we've tried to make it into piece parts, because, rather than try and build a whole search engine, a lot of people, I'm not interested in building a whole search engine, but I do know that I can build this component of a search engine much better. I can improve on it. And this is where, we're allowing people to get involved and taking little components, and Mahesh will show you little components, and improve on those little components rather than having to try and do the whole thing. And also, we're expecting people to take these little components and apply them to other things that we didn't think about. So we're thinking through this. It's going to allow more people to be involved with IP tools. And also the nice thing is going to, as an open source, it's going to lower the cost. So it's going to be easier for people to take advantage of these.
Sam, let me ask you a quick question, and maybe even a couple of questions. Can you talk a little bit about how the, I think it was the Georgia intellectual property group, which, if I'm not mistaken, was the first one in the United States, and now there's an Illinois chapter, as it were, and there's discussion about an Ohio chapter. Can you talk a little bit about the impact, the influence, maybe, or just even what that setting helped with regard to this particular tool?
Yeah, that's a good point, Tony. So I'm on the board of the US IPA and the Georgia and the Illinois. And what this is about is this is an initiative where we're trying to bring together people within the IP community to help drive IP education, drive a more efficient IP ecosystem, and make it more inclusive and have inclusivity and diversity there. Those are our 3 pillars. And the unique thing about this is we're trying to represent the average citizen. And that's where the pillars came from. The fact is that the average citizen, most people don't understand what IP is about. So we need to educate them to see and help them appreciate how important it is and how it's around them everywhere. We also need to make sure that those people who want to participate in the IP ecosystem can do it efficiently and eliminate the friction for people to get in, to get their ideas protected and enabled. And we call that, we talk about the creators, the protectors, and then enablers. And so CPE, we try and get, that's the second pillar. We try and get CPE together so that everybody's working effectively. And what we're doing here, just to be clear, is we're working with a lot of existing organizations. There's a lot of sort of siloed organizations. The intellectual property legal group. We have inventors associations. We have VC groups. But we're trying to bring those groups together and talk to each other. And one of the things they're doing, they see is in terms of the ecosystem, the PQAI is another capability that they see will help the average citizen and help the ecosystem work better. So we have the support of the Georgia IP Alliance, the US IP Alliance, and we're working again with the Illinois and Ohio, and it's spreading throughout the country. So very good question, Tony. Yeah, it's part of this whole initiative to get IP awareness and engagement all across the United States. And actually, it's even going globally. So with that, what we're trying to do here is really tackle, like I said, the problems with some of the tools and some of the things that users are facing. And again, we're trying to push the envelope here. We're not trying to make incremental change. We're trying to make big change. So one of the things we know is that it's really hard, and even the patent offices will explain that it's very hard to do, effective novelty search. So, we set about creating a tool that doesn't take any training, that you could just, as a regular inventor, just describe your idea and get some effective search done. And one of the things in here that we're pushing the envelope is, 80% of the rejections from the patent office include 103 objections, the obviousness aspect. Most inventors don't realize that the examiner will combine things to get, your idea. And so we took a shot at that. And I'll be the first to admit, Mahesh and his team has done a great job, but it is really hard to start trying to combine things. It's hard enough to do a prior art search, but then when you say, hey, I'm going to try and combine things in a logical way, it's hard. But you'll see we've taken a shot at it. One of the other things is we know that people are spending a lot of time, with the results from these search engines, trying to figure out. And so we've tried to take a novel approach there, as you'll see, about pulling out the novel concepts out of the documents and aligning it to your idea. So hopefully this makes it much easier for people to figure out, is this this piece of prior art really prior art or not? And then you're going to see we even looked at the whole question of, everybody's saying, how many documents does your search engine contain, in terms of the search? And we just really see that that's a really limiting approach. So we have a really interesting approach, which we're calling self-organizing repository of prior art. And we should show you how we try to take a crack at that in a novel way. So again, there are a lot of problems out there. We don't know them all. We've picked some. This is where we want the community, both users and researchers, to say, hey, here's some other problems you could be addressing. For example, we haven't done anything with 101 or 112, but there's probably lots of other ways, lots of other problems out there, and lots of ways we can solve them. And we want the community to help us. That's what we're about. So let's just take, for example, the self-organizing repository. So again, rather than looking at a search engine and saying, this search engine has to download all the material, we thought, what about if we made it so that search engines could talk to each other? And so if you did a search within your search engine, your PQAI search engine, and it had maybe the US patent database in it, but you really wanted more, of course, you might be able to look within your search in a directory of other search engines, PQAI search engines out there that had other directory which had other databases to them. Maybe it's the EPO, maybe it's a private database of documents, non-patent documents. Now we're going to have the ability to allow you to pick some of those and send out your query to those other databases through a vectorized approach. And those systems could run that query and send it back to you in a secure way, and you'd have the results from those databases. We think this, this whole idea of having a global directory of data sources and you being able to choose those and people being able to expose the data they would like to share is really a novel approach to this whole problem of, did I do a complete search or not? So that's, one of the pieces. We're not going to go into that today, because we're really going to be focused on the search engine piece and that performance. But we just want to reference that, and we'd be happy to talk about that offline. So I'm going to turn it over to Mahesh, and he's going to show you the tools and what we've built. Thank you.
One quick question, though.
Sure.
Before you move on, because I think it might be relevant. I think a fair number of people in this audience might be aware of BigQuery. And some of the databases that Google has made available. Can you mention just briefly if that sort of repository would be one that theoretically could be associated with this, or does it have to be a PQAI specific type of server orientation?
Well, it needs to be connected into a PQAI search engine, and the point here is that we're going to be sending out basically your query in a vectorized form to the other search engines, the other PQAI search engines, so they can go and do the query on the databases they have access to. So just a raw database, that doesn't really help you, because you need someone to go through it. You need something to go through it and pull out those components, those documents that are relevant to your idea. So that's why it needs to be connected to a PQAI server to enable it.
Okay, well, thank you. That's
Sure.
helpful. I know the guys at Google are generally pretty into the open source application and generally pretty interested in progressing a lot of the same things that you guys are talking about. One other quick question,
Sure.
I'm sorry, Mahesh, because of course we want to get into the tool, but I thought this was an interesting question. Excuse me. So one of our audience members wanted to know if you had patented any of this. Since we are talking about patents, now you've said open source, but that doesn't really mean that you aren't applying for applications. There's no law that says that patents only have to be used in commercial applications or for licensing or for other things. Lots of people patent things and then make them available with various open source licenses. So what are your thoughts about any of the advancements or innovations that you've created here in patents?
So we have, there have been some patent filings around this, but, AT&T has done some stuff, but AT&T and others have contributed their patents in the spirit of open source to make it available for others to utilize. So, we have, you'll see on our GitHub site, we have the MIT license, open source licensing arrangement, which I think is well understood. And so we are trying to make this available to everyone to utilize. Hopefully that answered the question.
No, it does, and that's a great answer. I think most people, and again, I don't want to get too far into this because this is a totally separate topic for a total, but patents are bad. Patents are anti-open source. And of course, it's not really true. Theoretically, you have to own something to be able to give it away. So the whole idea that you wouldn't want to take advantage of the system in order to make sure that you have control of what happens next.
Right.
And you guys have done that. Yeah.
Exactly.
So very good. Outstanding.
Mm-hmm. Okay. Well, let's switch over. I know everybody wants to see the tool and get into the technical pieces, and Mahesh is going to go right there. Mahesh?
Yeah. Thank you, Sam. So thank you everyone for being here and attending this webinar. I'm going to take you through three major pieces of PQAI. The first one is the search tool itself. The second and third are more directed towards people who are interested in building new stuff and developers. So those are the first is the API integration piece, and the other is the actual code and where you can get it from. So what I'm going to do here is stop my screen sharing for a while so that I can share my browser window. Just give me one moment for that. Okay, so you should be able to see the PQAI UI right now. Sam, can you confirm?
Yep, I can see it. And
Okay.
to be clear, everybody, you can go to this site. It's available to everybody.
Yeah. So regarding the UI, you would see this is like dead simple. You would not have seen a search platform more simpler than this. All you need to do is type in an invention and click the search button here. And what I'm going to do is also pick one of the demo queries. It's named auto adjusting display, and briefly to tell you what the idea here is. If you are reading, for example, some news article in your phone, and if you see that that the text is too small from your facial expressions, maybe the phone will be able to judge that you are not able to read it comfortably, and then it will increase the font size. So that's the idea. And let us see what comes up. Okay, so first of all, there are a couple of things about PQAI which you would see. Okay, this is just like another search engine, and I put in an idea and then I get results. But there are things about the way we have designed this, which are deeply rooted into the philosophy of how we want the search to be accessible to people. First of all, we do not show as in hundreds and hundreds of results which you would typically get from most of the databases. Our approach and our objective here is to show you a handful of documents in which you get really a mix of the information so that you get a good sense of what the prior art is. If we look at any of the results, so most of these results will be related to how to sense the facial expression of the user, and I've gone through results, so I'll just directly take you to the one which I like the most, which is this one. And the way PQAI works is a bit different if you are used to Boolean searching. It's completely different than that. So what happens in PQI is at the very beginning, when you enter your query, it just gets rid of all the text. So it's like there is no keyword matching that happens. There is an AI model behind PQI which transforms all of this query which you have entered into an abstract form which we call a vector. And this you can think of, the way I think about vectors is like when you have some thought in your mind and before you speak it, the thought is there. It's not a sentence. When you are speaking it, then it converts into a sentence. And if you think about that abstract thought, the vector is like that abstract idea, which can be matched with other vectors which are formed from all the documents that are there. And ultimately, the benefit that it gives you is even if the words that you are looking for are not there in the result, you will still get relevant text. So if we look at this particular result, it says it's a facial expression detector. That's fine, we use those keywords, but it does not use any words, for example, related to font or font size. What it says is it will render some graphics um, according to your facial expressions. So the detected facial expressions may include squinting, blinking, winking, facial muscle tension. And on the basis of that, it can increase, frame resolution or screen contrast and things like that. So in a sense, this invention is more like, a high level idea. It's not exactly what your idea is, because your idea is like a subset of this idea. But you can say that um, the graphics could be font, for example, right? So you kind of detach yourself from the exact way in which you have articulated the idea, and you go into an sort of an abstract realm, and there you can match with documents which are explaining similar ideas in a much more different manner. Another important thing that we have been paying a lot of attention on is the mapping feature, which we have spent a lot of effort in developing this. Why? Because I personally have worked as a prior art research analyst for like couple of years, and the what I see is even if you give some inventor, let's say 50 relevant documents, and you ask them to go through it, these are all relevant, and there may be like a very good prior art in there. It's like 50 documents are too much for people who do not read patents, for their job, right? So it's like reading a complete book for a single search. That's why we feel that if you can actually cut down on the time that it takes for people to analyze results, that is where a real benefit of AI is going to come from. And what we have done here is try to find out from within the document some snippets. So these are not sentences. There are approaches which will highlight sentences for you. But if you are familiar with patent data, you would see patents have like really long sentences. Like most of the sentence will like paragraph length. So we started with sentences, but we felt we should go down one level and then find out snippets, sub-sentence snippets from the text which make sense on their own. And this is still like a work in progress. We are still getting there, but ultimately our objective would be that the person can judge the relevance of this of any result without actually opening it. So if they open up any result, it's because they have decided, yes, this is relevant for me, and they do not spend a lot of time just going through documents that are not relevant. Another thing that I wanted to show you, which is unique to PQAI, is that right now I have done a novelty search, and the result that I just showed you, a typical inventor may think that, okay, I did not find a result which was exactly increasing the font size. So if I apply for a patent for this particular idea, I will get a patent. But what happens is, you file for this, and maybe the examiner will also not be able to find the exact same idea disclosed in any prior art. But what they are going to do is they are going to combine references and then still give you a rejection. And this is something which no other search engine does. So what we give it a shot, and we built this another feature which we call obviousness. So if you search for obviousness type of references, and again run the query through the system, what you are going to get this time is not individual results but pairs of results. And when I say pair of results, these are the kind of results which, if combined together, may lead to a 103 rejection, obviousness kind of rejection for you. And this is a very interesting problem in itself, as in what kind of references do you combine. And if we look at, for example, this particular combination, then if the first result, it was not there in the first 10 results that we saw, and the second result was there. But if you look at these results, it's like one is focusing more on how to manually change the the font size, or the font parameters, so as to make them more readable, whereas the other one is focusing more on the facial expression detection part. So in a hypothetical scenario, it could be that the examiner finds these two references and say, okay, you can detect, it is possible in the prior art to detect a facial expression and take a decision on the basis of that. And in the prior art, there is another document which is saying, okay, the font size could be adjusted according to the preferences of the user. And if you combine two, okay, this is obvious. So you can get these kind of rejections from the patent office, but there is no other tool which can show you in advance that these are the rejections you might get. So we are trying to do that as something new.
And again, this gets back to this gets back to our whole thing that we know we're trying to push the envelope here, and we're trying things, and it's not going to be perfect, but we're trying things, and we want people to give us feedback and work with us.
Yeah, no, that's admirable, because this is a really tough problem. So I'd like to take just a few minutes before we go much further, because actually we've gotten, I mean, I had a question myself, and then there's looks like 4 more have shown up in the question. So great feedback from everybody. So let's go through a couple of these. One of the audience members asked, since modular components are mentioned, what computer language is used? What is this, I guess, written in? Is this
So the computer language is Python. I'm going to discuss those modular components in more detail, like slightly more detail, up next, but the short answer is Python.
Okay, very good. I'll let you get to that in just a second. Now, I think this is an interesting question, because I think there's 2 ways to look at it. Is rigorous security in place to prevent unscrupulous individuals from scraping what we search? So I assume that this is, of course, relevant to the public site more so than the custom installations with the GitHub and the opportunity to install this behind a firewall.
Right.
So as far as the public site goes.
Yeah, I think it's important to understand that obviously if you download the software and all that, then you got complete control on it. But in terms of this service offering, we aren't interested in advertising to anybody. That's not what our model is or anything like that. So we have no motivation. We don't keep any queries or anything like that. And the point we do keep, anything we do keep, it would be on your computer. And Mahesh, I don't know if there's anything else we need to add to that.
Yeah, I think we do understand that whatever people are going to put in this box, it's going to be like very valuable to them. It's their ideas, and we have done everything that we can to follow the best industry standard practices. we do not log anything which the person searches. There is an option here, for example, to bookmark some of the results, but that also is saved only to your browser. As soon as your query goes to the server over a secure connection, the results are computed and no trace of it is kept on the server even for a second, even temporarily. So it's
Yeah.
like we'd log nothing.
We definitely appreciate the, again, the security aspect of it.
Okay, do search queries work better if the writing style is similar to the style used in patent applications, for example, like in patent claims? So anything about the nuances, patent text, of course, especially the claim language, is stylized in a way that is not traditional written English, just as an example. So, is there a benefit to the way you might put together this description?
That's a very good question, Tony. So yes, there are nuances to this to this whole AI model because it is trained on patent text. So if you put in patent text, it is likely to work better. If your query is like couple of sentences instead of, let's say, couple of keywords or just one sentence, it's going to work better. If you put in claims, however, and the claims are like too broad, using like overly broad language such as communication device or things like that instead of mobile phones and things, then the performance will actually degrade. So there is, I feel that there is a balance between two extremes where you are using too casual a language or versus you are using too abstract a language. So if you describe your invention as if it looks like an abstract of a patent, it works best. And I think that's because um, patent abstracts are a big part of the data on which we have trained our system. I'll talk about those aspects also, but yes.
Tony, I know you want to do some questions. I want to make sure Mahesh gets through some of the analysis piece we've done, because I think your audience will really find that quite interesting.
Yeah, I was going to suggest the same thing. We have 4 more questions, but we'll keep those until after you guys have finished. So,
okay.
Yep, please go ahead, continue demonstrating.
So the next thing that I'm going to show you is like this resources section here. First among them, the API. So the API is actually an endpoint on our, on our public server, where you can also send requests programmatically, not through this interface, but imagine that it's an app that you are developing or it's an in-house tool that you have. You can embed the functionality of PQAI without downloading the code, without setting up anything. All you need to do is, send an email to Sam and, ask for a token. So once you have a token, you use that token to send a number of different kinds of requests to PQAI. If you want, for example, if you just want patent data, if you are doing some kind of development using patent data, not even a search engine, you just want patent data, but patent data is huge, right? So if you want to download the complete USPTO database, it would be like a couple of terabytes. You can get all of that data through the API. You have access to almost everything that is there in PQAI through the API. So that is one possibility for developers. I'll just directly switch on to the GitHub site. If you want to do something with the code, look at the code, download it, fork it, play around with it, you can download the complete code from GitHub. This link is there on our website, also on the search tool also, and we have also given all the steps that you need to create maybe a PQI server for yourself. So you can develop a complete search system, maybe with your own tool, your own literature documents, and it's really easy to do. It will take like a couple of hours, but you can do it. The last thing that I wanted to show for people who are interested on the development side are these modularized components. And when I say modular, it's like this is something that we have started doing just recently, a couple of weeks. We have initially we had just one repository, which is PQI. So everything that is there in PQAI, which is like near around 20 different modules within this single repository. What we have started doing is pulling out some of the um, components from there, which may be like general purpose, and then putting them in separate repositories as independently deployable services. So that means if you want, for example, to if you want to use a patent database, in-house patent database, or for some application, you can just take this PQI DB service. And if you want to do something with the vector representations of patents, you just take PQI encoder, and you don't need to worry about the rest of the stuff that is there in PQI. There is another reason why we are doing this is so that it is also becomes easier for people to contribute to um, one of these modules. So if they want to contribute to PQI encoder, they only need to understand what PQI encoder does, and then don't need to understand about rest of the code. So I'll stop here, and I'll get back to the slides now. If there are any questions in between, I'd be happy to take.
Okay, while you're doing that, then why don't we ask one more? Like I said, there's several here. This is great. Thank you, everybody, for submitting them. We're going to get to as many as possible in the next 15 minutes. What patent databases are you using to train search? Is it US, or do you have information from other jurisdictions as well?
So as of now, we only have the US patent database. For the search, we also have um, around 10 million research papers in the database, which are like openly available on the internet. But for the training of the system, we have only used the US patent data, not from other jurisdictions.
Okay.
But
Right.
we are working with some partners to get more jurisdictions into the mix, so to speak.
So okay, so I'll quickly go through how the system works, and since PQI is open source, I am able to share more details than anybody else, any other participants on this webinar. So this is in a sense how a simple working diagram of how PQI system works. Starts from a query. The query is vectorized. The vector is sent to an index. So this is a vector index. So you don't do keyword matching here, but you compare vectors, the query vector, with all the vectors of the patents that are there in your database. And where those patent vectors come from, they come from the patent database. You pick each document, you pass it through the vectorizer and put it in the index. So it's like a big vector matching operation. Right now we have around 13 million patent documents in the index that translates to 13 million vectors. And after that comparison, whichever vectors are the most similar, we pick the patents associated with those vectors as our first level results. This process is actually very fast. This happens in fraction of a second because the vector indexes can do these comparisons really fast using some specialized structures. However, when I say coarse results, it's like you get related results, but not the exact right matches. You do not know if the first result is actually the best prior art, and not the 70th. And for that, we use more specialized, again, machine learning models, which we call re-rankers. And what they do is they will reshuffle these documents so as to bring the one that is actually the best on top. The vectorizer and re-ranker are like, they differ in their performances, because vector is very fast, but it's not very precise. The re-ranker is slow, so you cannot use a re-ranker as your main search engine. It will take hours and hours to go through the patent data, but it is very precise. So we do the search in two stages. One, the coarse results, and second, we reshuffle them using a more precise system. The vectorizer and the re-ranker, they form like the backbone of PQI, and I'm also going to share how we train these models. And both of them are trained using the exact same technique. The only difference being that the vectorizer and the re-ranker, they differ in their internal structure. From the outside, you can also replace this vectorizer with the re-ranker, and the training will still be the same, and they will also do this exact same thing. For training, we created actually a very specialized data set. We created 92,000 samples in this data set, and this is actually kind of an artificial task. Think of it like this: you have been given one patent, which we call as anchor, and then you have been given one citation of that patent, like actual citation which was given uh, by the examiner at the patent office. And all of these anchor patents are those patents which have only one citation. So there is no question of, this is more relevant, this citation is less relevant. They have just one citation, so that's it. And then we pick 10 other patents which are very similar to anchor, very similar to positive. Why? Because they share a particular CPC. All of them share a particular CPC. So that means if the anchor patent is related to heat exchangers, the positive patent is also going to be related to heat exchanger because it is the only citation that the examiner gave. And then all of these negative patents which we are bringing into the system, they are also related to heat exchangers because they are sharing the same main CPC. We shuffle them and we give them to the vectorizer, and we ask the vectorizer, okay, vectorizer, here's your anchor patent, but we do not tell it, which is the positive patent. So these are shuffled, and then we ask the vectorizer to create the vectors, and we compare those vectors, and then we see if um, the if the vector that has been created for each of these positive and negative patents is the positive the most similar vector or not. And when we start to do this in the initial phase of the search, then what happens is, the vectors are, the model doesn't know anything, so it will create like random vectors for anything. So the position of the positive in the ranked list is pretty much random. So sometimes the positive is on the top, just out of chance. Sometimes it's at the bottom, sometimes it's in the middle. When it comes on the top, we we appreciate the vectorizer, how by not penalizing it. So the lower it ranks the positive, the more we penalize it during the training, and the more it updates its parameters. Ultimately, a phase reaches where the positive ranks more towards the top than it ranks towards the bottom. There are a number of metrics that we use to measure this during the training, and I'll share with you one metric and a couple of models that we have used during the training. So here you see, if you use word vectors and just average out all the word vectors, you could create a vectorizer like that. And this number represents the number of times in which this positive patent was actually ranked on the top. So if it comes at a second place, we say, okay, this is a failure. If it comes on the first place, then we say, okay, this is success. There are other metrics for this, but here I'm sharing only the one that is simplest. And you see that different models work differently. So when I say vectorizer, this is the vectorizer. PQAI BERT is the vectorizer that we are using in production right now. This is a fine-tuned version of sentence BERT, if you are familiar with that. And the rest of the models are basically interaction-based models, which are used for re-ranking. So they are very slow, but they are more precise. And you see that the best re-ranker we have right now still does a good job of getting the right result on the top, but it still gets that only 38% of the time actually on the top. Rest of the times it may be at the second position or at the third position. So you see that even the best state-of-the-art techniques right now still have a way to go, and this is the number we basically want to keep on improving. I'll talk quickly about how we used one of the modules of our system, the vectorizer itself, to test it on the qubit gold standard collection. So a word about the methodology. Initially, we got a list of those 5,000 or so patents from the GitHub. And since we only work with US data, we do not have like the global database right now. We discarded the patents which are non-US, which left us with 1,654 patents. And then we deduplicated them on the basis of their family ID, because we saw that for some of the cases, it's like the application is there and the patent is there, like the example that I've shown here, which have the exact same claim and abstract. And when we are doing the split between the training data and the test data, it is possible that one of these goes into the training data, the other comes into the test data, and the results that we see will not be, they would be high, they actually were high, but they are not representative of a real world scenario. So these are the numbers which I'm sharing here, regarding as in how we did this classification. We just took the first claim itself, and we did not do any pre-processing whatsoever. So you can say, this pipeline is not actually optimized for classification, which, if you do, you could get better scores. But this is like a real world indication, a very realistic indication. If you pull the vectorizer from the PQAI code base, give it a patent, get a vector out of there, and you put a single dense layer, like the simplest neural network that you can apply, a single hidden layer followed by a single neuron for classification of 1 or 0, with almost no hyperparameter tuning. So it's not something that it's optimized over and over and over. This is like a realistic scenario where if you pull the vectorizer right now from the PQAI repository, you put a dense layer in front of it, you are going to get these scores. You will get an F1 score of 0.86, precision and recall again in the same range. And this is the confusion matrix, the correctly predicted ones and the wrongly predicted ones from an actual set of 150.
So I think this, we're just trying to show you the way in which we tried to measure the performance of PQAI, and we just think one of the things you're going to hear about here is we think these types of tools are really important for the whole industry. So thank you, Mahesh, for going through that. Again, we're open and happy to do more discussion on the technical pieces at any time. We're looking for feedback, both user feedback and technical feedback on what we're doing. We encourage everybody, get involved, help us, improve the code, add new components. There's a lot of creativity out there. Take advantage of it. Help us add new features and components. Again, we're about integration too. So we have plugins that you can plug in, so you can have PQAI, search right integrated into your website. And then, as Mahesh mentioned, we have the API. So if you're developing a tool or something like that, you can now integrate PQAI into it, or components of it into what you're doing through our server. What we're also trying to do, as you see from just what Mahesh showed, we believe that if we can get the industry together and help develop, benchmarks and toolkits to perform the benchmarks, it's going to drive the industry as a whole. It's a good thing for everyone. A good example is, ImageNet, where everybody was trying to figure out how to do better image recognition. The industry came together, they created a data set, and now everybody could start understanding how well am I performing, and maybe more importantly, where's my model or my system failing? And so now you can, focus in on that and get that improved. So with that, again, Tony, thank you for this opportunity. We really appreciate it, and open to questions.
Well, we have the questions. Yep, we want to go ahead and take some questions.
Sure.
And survey at the end. please take the survey. It's only 5 questions. The first being, would you be interested in helping with the development? So, so let's ask a few of these questions. So when selecting the document pairs for obviousness, do you keep in mind that documents have to belong to technical fields related to the application? So you did mention how in your trainer, you were applying from the same CPC code. Is that the same? Is there anything in the obviousness application or aspect that would do something similar by when looking at the pairs?
We do not do anything of that sort explicitly, but the approach that we follow is something like this. First of all, we extract like a big list of results just by running the query. And since all of those results are, in one way or another related to the query because they're coming from the query itself and similarity of the vectors, we try to find what I can say, like coherence or a catalyzing effect among the documents to see if combining the two creates a prior art which is stronger than both in terms of how many elements it is disclosing and to what extent. So we do not do any sort of this is a very complex mechanism, and we know that our approach right now is like it's a first cut implementation of this thing. So we are also writing like a white paper for this, which we'll be publishing shortly. But yeah, right now it's like a very basic approach where you combine those two things as to make a combination, as if you stitch those documents together. Will it be a better prior art? So you can think of it like that.
That's great. And yes, I mean, here's another, just a perfect example of ways in which the community can help to provide ideas as well as to actually look into things. Another question, we've only got time really for 1 or 2. There are about 3 or 4 in there, so some of the ones will end up in the report afterwards. I'll ask the guys to respond directly to those. Do you aspire this tool to be used at patent offices? How do you think this will change your future development of the tool?
Well, yeah, exactly. We think it would be beneficial for patent offices to provide a tool that's transparent so everybody could see what was going on, and allow people to run a query that the examiner might run so that they could say, okay, I understand what the examiner is going to come up with in terms of prior art. Now let me build my arguments as to why I don't think this is prior art. We think this could make the whole patent process much more efficient and more trust too. That's a key thing. When you don't let people see how the examiners are doing their work, there's this element of trust that's lost, and we think this could really improve the trust level. So
okay,
hey,
this will be our
keep
last
pushing
question.
that idea. Keep pushing that idea. We like that. We've been talking to a number of patent offices, but as you can imagine, they're very cautious.
What's your take on a similar tool for patent infringement analysis? Do you think this kind of tool with a good amount of accuracy is possible to make in the near future?
Well, I think this is, yeah, the short answer is absolutely. I think a lot of people are looking at different applications for this, and it goes both, invalidity, of course, and infringement. Yeah, I expect people are going to take components of what we've done and apply it to developing tools like that. There's lots of pieces. There's also landscaping. There's also innovation. I think this can go in many different directions.
All right, well, we are at the top of the hour. Thank you everyone who stuck around. Most of the audience, like with most of these, stuck around for almost the entire time. Probably as many, if not more questions than we've ever gotten on another episode. So great interest and great amount of interactivity with the group. So thank you so much. And with that, I will thank the 2 of you again for your time and for all this effort. I mean, this is an effort that's open source and available to everybody. So this is not a for-profit type of a situation. And so thank you for putting all this work into helping the community. And with that, I think I'm going to go ahead and close it. And again, thank you to the audience for your time. And we'll look forward to seeing everybody. You'll be seeing a note soon, June 1st. Representatives of the U.S. Patent and Trademark Office will be joining me. And so speaking of patent offices, you'll get to hear a little bit about what they're doing as well in a coming webinar. So again, thanks so much and have a great rest of your day.
Thank you very much, Tony. Appreciate it.
Thank you, Tony.